All right, let's get started. My name is Robert. I'm the API guy at Tricentis, and I really appreciate you guys came here. I see the most important people are here today, so that's fine. You know, the topic is extreme automation, and you probably think, is that another bullshit bingo word? I guess in software testing, I think it is, but where it's coming from, and that's why I want to ask you, has one of you guys an idea why this term might come from? No, it's from the automotive industry. So vehicle manufacturing and that stuff, right? You guys know these guys do a lot of automation, and this is where originally it's coming from. And this is why I will start my presentation with an analogy, with an example from there. I think that will help us a little bit to understand the whole topic. Most of you guys know that already. Before I go into the other topics, but this example, when I used to be at technical school, when I started my career like 25 years ago, I know I don't look that old, but it was early 90s. They brought us into Upper Austria to a facility where they build engines for BMW. And what I've seen there was exactly things like this. They had like carriers where engines were driving completely autonomously around the whole facility and plugging into certain stations, plugging out and go somewhere else, right? Completely automated already. And what these guys were doing there, and that's a different perspective here now, what these guys did is they tested these engines and fully simulated, right? So what we're missing here is basically everything you think a real vehicle needs to have in order to do a test drive. But these guys don't connect all these components because they can influence, of course, the test results. So they really want to focus on the engine. It's complicated enough, so they simulate the rest in order they can focus on the engine. So the reason why these guys did it, because it doesn't make too much sense, and it's also a lot of effort to put an engine into a vehicle frame, put all the stuff in there, like brakes, windows, etc., and do a test drive just to find out, oops, the engine is broken, right? So they test everything up front, and they're not doing it only for the engines. Of course, they're doing also for brakes, for everything which is going to be inside your vehicle. I think that makes a lot of sense because everybody knows there's a lot of effort and that's probably not very efficient. But again, these guys did this decades ago. Okay? But it's easier to understand there probably because it's more obvious. It's more, you can see that. You start the engine, smoke, doesn't work, you know immediately what's going wrong. And what's the link to software testing? In software testing, before we have a chance to get out what's the real problem is, we need to analyze what we're currently doing. This is, by the way, an engineer deploying a monitoring system into our environment, and he doesn't know if it works or not because nobody let him plug it in somewhere. So he has no other option just to deploy it. Of course, this analogy, don't get confused. We're talking in our case, of course, of services and software, right? But these guys are not delivering broken systems because they're too stupid. They don't have another option. They don't know. They can't plug it in somewhere. So we end up in huge environments where we have broken services which are not reliable. When you start them, they crash, they're incomplete, because some services just need longer to develop or need more often to be tested. So that's how we end up in test environments. Who of you guys experienced this already, that he has been confronted with broken systems in test? Can you raise your hands? Okay, the rest of you guys didn't test in SOA architectures, I guess, but it's a common problem. That's a really big problem, and this leads into huge error analysis, because you always need to find out who is breaking now my test. Is it my application? Is it the application I'm connected to? Or is it any other downstream system? Because these systems get incredibly big. So you need to call people and so on to find out what is the problem. And you know, when you're a tester in there, that's a lot of trial and horror, actually, right? So when I used to be in a project, we called that the tester's hell, right? Because whenever you try to do something, it breaks. And when you think about automation, forget about it, right? Sometimes it works, but in very late stages, after you have to resolve many, many issues, after you have invested a lot of time to resolve this, and, you know, I don't need to name all the others, but the most important thing is we cause delays, and then we tend to ship broken things even into production. And you know, we hear all the time these cases where they have critical issues in production, and this leads also into chaos inside your organization where everybody is involved from top to down, right? So that's something, if we could avoid it, I guess we would do it, okay? But in order to avoid it, we need to understand that each and every application has different upsides, but also downsides. For instance, a UI application could be a mobile app, could also be a browser app, or something which has a UI interface. But these things need frequent changes because we humans, we like beautiful UIs. We like responsive UIs, right? So we need to try and test again and again, back and forth. Then UX team comes in, go back, do it again. Then, like we heard in the track before, frameworks changing. Like these UI frameworks are extremely complicated, actually. You have no idea what knowledge is inside in this UI layer. And when you change it, that makes it very brittle. But that's a real downside of UIs. On the other side, we have the backend. And once a backend interface is described, that's fine. Because computers don't care if a button is blue or green. They don't even need button. They love XML, or some system even love fixed length messages, right? They don't care. So we define it once, and usually it's stable. Of course, we add new stuff to it, but it's nothing compared to the changes on the UIs. On the other side, a UI has very low complexity, right? It's compared to the backend, it's nothing. So what we need to be aware, and that's not everything, of course, right? I just wanted to highlight two things, two upside and downsides of UIs and backend systems. But we have really a problem with the frequent changes and the complexity in the backend system. And if we connect this, then we have like a cross multiplier, right? And it means it's not like combining these problems, but you get like a multiplier problem. Because one time the UI changes, and the other time the backend is down. So if you have just a couple times to test, then it's very likely you will not test very often, right? So when I used to be in the customer projects, they sent me like for 20 days somewhere all across Europe, and I could test like 5 days of the month. That's a waste of time and money. So we need to understand we need to split those in order to not increase the problem, especially in early stages. Of course, later we want to test it end to end in one environment, but we need to, when the systems are stable, we can do that later, right? But first, we need to do it like the Romans, we divide and conquer it in order to have it under control. That's also a very normal design pattern in information technology. If something gets too complex, divide in order to conquer it. Otherwise, you got lost in complexity. So we have two techniques there, and that's also what my track is about. The one thing is service virtualization, the other thing is API testing. Because what you should do is, in early stages, you test the UI without the complexity of the backend. It's enough that we have the frequent changes. We don't need the complexity of the backend, and by doing this, we increase the efficiency significantly. But not only by 10%, it's like 50x in some cases. I usually had numbers here, but some people say, why it's 50x? I say, it's just huge. You just need to try it. And think about the hell you've been before. And the same is for API testing. We can test the service without the UI. You know, the UI testing is slow and the backend is complex. We need to run a lot of tests. Well, if we use the UI, not even a nightly regression will make all the tests. So we test it without the UI, because also the UIs are brittle. And this increases the efficiency of service testing. Okay? This brings me to the next topic, the techniques. Let's have a closer look how API testing and how service virtualization works and how it's meant to be implemented. So we have, for instance, the development phase. This is usually the phase where the system's the most completely broken or unfinished, of course. So it doesn't make sense at all to plug it in anywhere, but if we have simulations, we can plug it to simulations. For instance, we don't have the UI available, then we test it with API test cases, because usually we have the definition already, so we can run already, send message to it, and verify if the output is correct. So that's one part of the simulation. The other one is, for instance, if we need to connect to a downstream system, we can create a virtual service. We don't need the complexity of a full virtual service, but we just need to provide a reliable environment where we can run our tests against it. And this could be, and that's just a proposal. This is like we do it at Tricentis, but of course each and every one of you guys need to find out what advantages and disadvantages of your components, but of course also what's the need for testing of your components. And of course unit testing is something everybody should do, but of course, integration testing, and if you do risk-based functional testing, it depends on how much functionality you have in your product, but you can do that with simulations in a very early stage. Think about the engine. They assemble the first time the engine, and they just want to start it, for instance, right? I don't need to put it into a vehicle first. I just need to put some fuel in there, and then I do the next test. Maybe I put some more gas in, set it under stress, see how much power it delivers and how much output it delivers in, whatever. It's like we need to give the people the opportunity to even test. And we need to give them the possibility to test as often they need it. If we tell them, oh, you can test there from 9 to 11, that's insufficient. They need to test whenever they need, and whenever they check in, these tests should run against, or must run if we want to do extreme automation. It's actually continuous testing and automation, but anyway, this has to be performed like with every check-in, ideally, right? And then the next stage, when your system is not so broken anymore, you can extend your tests. But if your application doesn't pass the first 3 quality gates, why should I move it to the next stage? Push it back, fix the bug, and then we meet again. And if you meet all these criteria, we go to the next stage. If we would push it through the whole pipeline and find out in load testing, for instance, it doesn't work because it doesn't really integrate, why should it even go there, right? And we have to do certain things overnight because these tests usually run much longer. Right, so a full regression portfolio runs sometimes 6-7 hours, so we better do that when we are sleeping. And then we move it to the next stage, for instance, where we have like every release, sprint release, where we do like UI-based performance testing, for instance, with Flood, or you do like user acceptance testing, or you still can do end-to-end automation on UIs, or you still can do end-to-end automation with APIs. Because many of you guys probably also have business-to-business, where other companies integrate into your ecosystem without having the UI. So you could even test this already on API layer. And this is really something, what we need to do is we need to do automation all across these stages, and we need to pass the quality gates, and we run them whenever we need them, right? That has not really something to do with extreme automation. This is something where I would expect all of you guys go one day, right? You start now somewhere with a DevOps continuous pipeline. You're happy that you have automated something, but this is something where you should go. Call it extreme automation, or as I've heard yesterday, hyper automation. I don't know what's next, but automation is anyway the dictate. And you should try to do it all across your continuous pipeline. Let me give you an example. What's one really significant if you do like API testing and service virtualization in an early stage, and that's the same example from before. We have the app here, it's surrounded by other systems, and it's all simulations. And then we have other participants, Team B, for instance, they run System B. But they have a different view, but they don't need everything anymore, right? They have a limited scope on their environment where they have dependencies, so they don't need to have a full simulated environment. And for instance, Team C has the same as Team B, just from a different perspective. And then we have Team D, which has only one connection to System A. And let's have a closer look on the dependencies between System A and System D. Let's say System A is a mobile app, and System D is a service. Could be a microservice or any service running in your environment, also in your middleware environment. That doesn't matter. It could be even a mainframe. But in this case, it's a REST service. And what the mobile app actually does, when you have an app and you click around on your mobile app with your fingers, and then you click a button, then it actually, a request gets sent. And in our example, it's like a pet store example. Just imagine you click get pet with ID number 4, and the service would respond, for instance, it's a crocodile, right? And you see that on your display. That's, of course, simplified. Usually there are more calls, but that's the principle behind it. It's like requesting information from somebody, from a service, and get a response. And that's how it looks like in REST. You have like a get method to a resource with the pet ID number 4. I have even this. Yeah? And then you receive, for instance, in the response, status code to everything okay, and that's the relevant information which will be displayed on your UI. Okay? But we were talking about the problems of a UI. It's changing constantly when we want to automate it, and also, for instance, the execution is slow. Because you need to click around until you reach the end when you can submit the button. That's slow compared to what we do with API testing. And then on the other side, you have the complexity of the backend, and also you have a lot of data variations you need to test. Just if you combine this slow execution with a lot of data variations, and even the services pass this out, and you have to update the UI all the time, that's a huge problem already, right? But here's a solution. We can, instead of the UI, we can use an API engine, for instance, or any API tool, basically. But of course, I'm working for Tricentis, I will propose to you the API engine, but you could use any API tool. But the API tool sends just the same request as the mobile app would trigger. You could capture the requests between upfront, or you can create it out of a definition, and you will get the response, and you will verify the response. The result is completely the same if you verify it on the UI, or if you verify here it in the response, it's like in JSON. But we're still, we're still having problems from before, but what we're now doing is we derive the advantage of the stable interface because we're testing on a protocol level, that we have suddenly a stable interface on the client side. Because we're using the API tool, it's using on the protocol layer. So we have the same benefit like the backend services also for our API engine. On the other side, we replace the slow execution with super fast execution. It's like 100 times faster. You don't even realize that the messages get sent and verified. And you tackle this, you can focus on the service, right? If you have a mobile app, it triggers sometimes even many other services. You don't even need that. You focus really on the one service, and you test only this one. If it has downstream system, you could think of service virtualization, but that's coming a little later. But you still have a lot of data variations, but because there are probably millions of pets in there, right? But that's no problem. You can do this all data-driven. You have usually an Excel sheet where all the pets are in there. You just instantiate all the test cases and then run them, and it's done like in a couple of minutes, all the pets will be verified, right? So that's what we did now. We test now. The test object was this one, right? So we test the service. So now let's switch the side. We have to test the mobile app as well, right? And on the mobile app, remember we had the changing UI. We simply can replace it with tools who can rescan UIs, right? So the tools out there, they do like all with dynamic control finding or whatever. They help you to deal with the challenge with the changing UI. And then the other side, the complexity is very low in the mobile app you really need to test. There is almost no functionality, almost. Some of them more, some of them less, but it's nothing compared to the complexity in the backend systems. And if you use a service virtualization tool, you have a unified interface. I'm not sure if one of you guys have participated in my workshop yesterday, but it's really easy compared to a system you don't even know where it is. But the simulation, you can bring it to you. You have it under control. You can do whatever you like with it. You don't need to call anybody else anymore when something broke, or if you want to do a negative test, just implement it. Put instead of 200 OK, 500 error, upload it. Oh yeah, my application reacts like this on a 500 error. I don't need to wait, or you probably know how it reacts because that's a common thing that servers respond with 500 error. But that's probably not the best use case because but on the other side, you can replace all the data variations with synthetic data because when you test the logic on your UI, you don't need all the pets. You need a couple of them just where UI tends to change. So you don't need millions of records there. This is also a maintenance question. For my UI test, I only need to test my controls, for instance, right? I don't need to test crocodile, rabbit, or it doesn't make any difference if the control displays what we receive. And if we do that, we can make sure when we integrate our systems that these can talk to each other. Because we could test them before, right? Very deep and very independent from the other system. And this is like integrated and functional testing before meeting each other. How many minutes was it? 2. All right, I got to speed up. Because we are using the same messages all the time, all the process. The components have never met each other, but they speak the same language, and that's a real big advantage. All right, but that's another problem you need to solve if you want to go for this, but you guys mostly know all that. It's early adoption. You need to start as early as possible, right? You can't really, if not everybody is on board, then you will never have the same outcome, right? And you need to automate across the whole application lifecycle, right? Then the next thing is you need for Agile. You create a function, you create a test case. You check in the functionality in your code repository, you check in a test case in your test case repository. When you hit the button, your test will be executed as well. And it will also identify if you broke something on the other end, if you are consequent on this, right? All the tests are running also, you build the very fast time, for instance, so you will have always confidence when you check something in that you didn't break something on the other end. So it makes you also sleep better if you're a developer. The third thing is you need to test across the whole testing pyramid. Unit testing is super important, but still people don't really like it to do it, unfortunately. I don't know how we can do that more. But all across the layer, of course, UI testing is still important for end-to-end, because we're going to use the UIs, and you can test if a control is working on that only on a UI test, and you can do that automated. And one important thing is automation also needs to be skill agnostic. If you have like gazillions of tools in there, all are completely different, some more complex, less complex, then you will have to train people on many different tools. And if you're lacking on resource somewhere, you cannot really switch because nobody would understand. But if you have a unified approach, then you also can move people from one department to the other. And of course, return on invest is very important for your management, because if there is no output, why should they do it? But, you know, extreme automation or general high automation rates gives us fast feedback we need in order not to build features on bugs, for instance. And this accelerates the whole development. Everybody knows who developed, who are building features on top of bugs. This resolving is a huge pain. And this leads to faster release cycles. And the tools you need for this, from a testing perspective, is, of course, continuous testing. We have a platform here which can do that, but continuous testing needs automation on the API and UI layer, right? If we do it manually, forget about it. And number one killer for automation is unstable environments and data. Just ask yourself how much time you invest in preparing test data. If you use a service virtualization tool, you define one time a test data set you will reuse all the time again, especially in the early stages. In the late stages, you still have to prepare, but it's different if I have to prepare 50 times a year test data or only 3 times new test data. All right, so service virtualization is basically the basement if you really want to drive your automation levels on an extreme level. And it's also do the right things and do it right. It's more about, if you go for it, do it right. Don't think you put like 2 engineers and trying to do that. The whole organization needs to do that. And I'm not sure if you guys know, we're doing this as well at Tricentis, and we got mentioned as, or evaluated as a so-called unicorn. And we want you guys also to become unicorns, but I believe a high automation rate and a very, very highly automated continuous delivery pipeline is a must to be there, to have in order to get really in the challenges we're facing today. Go to Google, Amazon, or all these unicorns, they all have systems like this. Thank you. So, yeah, we have some. Does anyone have some questions? I think we still have some time, right? Yeah. Are there any questions? No questions? So you can always come to our booth and ask about in more detail how we do that. And thanks for listening and thanks for showing up. Have a great day.